So the second section we're going to take a look at this week is 2.4, and this is on solving inequalities. So yesterday we solved equations, today we'll solve inequalities. Just a reminder what your four inequality symbols are. Less than or equal to, greater than or equal to. Here's a couple examples of inequalities. Okay, the one on the left, just a true statement. The one on the right is an inequality that could be true if you pick the right numbers for x. And there could be potentially lots of numbers you could pick for x that would make it true. But the way you check if a number works is you replace the variable in your inequality and see if you get a true statement. So let's say I wanted to check the number 5 if it's a solution. If I plug 5 in for x, what does that give me on the left-hand side? 15. And then is 15 greater than 12?
Yeah.
Yeah. So then 5 is a solution because I got something that was true. Now, let's say I plug in 2. 3 times 2 is 6. Is 6 greater than 12? No. So then 2 would not be a solution. So it's very similar to how you check if an equation is true. You just take your number, plug it in, and see if you get a true statement. Any questions on how to check if a number works in an inequality? Okay. So one type of inequality we're going to look at is a conjunction. And a conjunction is when you write two inequalities with the word and. Okay, that's a conjunction. X is greater than -1 and x is less than 3. Now, one thing we can do with a conjunction is we can take two separate things, two separate inequalities, and we can combine them into one. And here's one way you can combine them together. The idea is you put the letter in the middle, you put the smaller number on the left, and put the bigger number on the right, and then you have both inequalities pointing to the left, pointing towards the smaller number. And the way that kind of works is, let's do this in different colors. That inequality in the red box is right there. We had an x and a -1, and it was pointing at the -1. Down here, it's the same thing. X, -1, and it's pointing at the -1. And then the green box, x is less than 3. That's right there. X is less than 3. So it's like you take and you put them together. You do have to switch the order of one of them to make this work and put the variable right in the middle. Now, what if I had something like this? -2 is less than or equal to x, which is less than or equal to 10. That's combined together. How could I split that apart into two separate inequalities? Yeah?
X is less than or equal to -2. Okay.
X is greater than or equal to -2.
Greater than or equal to -2. Yeah, that's good. You switch that order there.
I said it wrong.
So x is greater than or equal to -2 and yeah,
X is less than or equal to just 10.
X is less than or equal to 10. So sometimes we take one that's combined and you have to split it, or take one that's split and combine it. Any question on that? Okay. What else we got? So the idea with something like this, this is an interval of numbers. Okay. Specifically, it's all the numbers between -1 and +3. But does it include -1 and +3? Isaiah?
No.
No, because it has those less than symbols. When you have an interval that doesn't include the number on either end, that is called an open interval. Open means it doesn't include -1 and it does not include the 3. Anyone have a guess what you'd call it if it did include the number on each end?
Closed.
Yep, it's called a closed interval. So we're gonna talk about 4 different types of intervals. Open and closed are 2 of the types. And these all fall under the category of what we call bounded intervals. A bounded interval is an interval that starts at a number and stops at a number. You might think, well, how could you ever have an interval that doesn't have a number in it? Has an infinity symbol. That's different. If you put an infinity symbol in an interval, that means it goes forever in one direction. If it continues forever, that's what we call unbounded. Okay, so bounded intervals start at a number, stop at a number. And one type of bounded interval is a closed interval. That's when you use a bracket on each part of the interval. And the bracket means you can include the number. So if I had a closed interval from like 1 to 5, that means you can pick any number between 1 and 5, including 1 and 5. And remember, it doesn't just mean integers either. You could pick 2.3, 2.714. You could pick any number between 1 and 5. Now, with an open interval, you can pick any number between the 2 values, but you can't pick the endpoints of the interval. So if I had an interval from 1 to 5 here, well, that means I can pick a number like 1.0000001 up to 4.9999999. Okay, I can't pick 1 and I can't pick 5. The other type of interval, it's just a combination of the 2. It's a half-open interval. You can have an interval that is half open on the right side, or you can have an interval that's half open on the left side. Just depends where you put the parenthesis. Wherever you put the parenthesis, that's the side that we call open. You could also say half closed, but they usually just say half open. Yeah.
So you kind of answered my question, kind of. So half closed, why don't they just refer one of them as half closed, one of them has half open, so that we know that one would be one and one would be the other? So if I just said half open would have to be brackets A, B, parentheses, and half closed would have to be parentheses, A, B, bracket. Like, why don't they just name one of them solely privately? So we do.
Yeah, I don't know. They give you the freedom to let either end be the open end and call it open on both. So, yeah. Right, so those are all what we call bounded intervals. If you wanted to see like what it would look like on a number line, well, if I did this one, it would be from A to B, open circle on A, open circle on B, shade between. The half open, you could do one like that. This time it wouldn't be an open circle on A. What kind of circle would we have this time?
Closed.
Yeah, it would be closed circle on A, open circle on B, shade between. And then fully closed, it would just be a closed circle on A and a closed circle on B. Okay. But notice here, there's no arrow. I shaded between the two circles and then I stopped. If there's no arrow indicating that it keeps going. When you put an arrow on it, that makes it an unbounded interval. Okay. Unbounded intervals use infinity. So here's an example of an unbounded interval. Closed circle on 5, shaded to the right. Here's another one. This one is an open circle on 5, shaded to the right. And you could draw the other ones as well. You could do it, closed circle on 3, shaded left, and an open circle on 3, shaded left. So if you had to describe, let's say, this interval to someone, and they said, well, what kind of numbers does this mean I can pick? The simplest way you could say it. What kind of numbers does that interval circled in green mean you can choose from? Yeah.
You can choose either 5 and then to infinity.
Yeah, so anything that's greater than or equal to 5, you could choose. So one way to say that is like that. So saying, what I'll do is I'll circle all these that are equivalent. When I just put a red box around, those are all the same thing. The first one here, this is an interval from 5 to infinity. The number line, that's a graph. And the top one is an inequality. You should hopefully feel pretty comfortable writing any 3 of those. They're all just different ways to express an answer. And you can see more pictures. I drew 2 of them. But if you want to see the other 2, you can, on the PDF on page 100, it shows all of them. All right, so let's try writing an inequality for this one. So that's an interval. I want to change it to an inequality. All right, so this is the kind of inequality where we would want to start with the letter in the middle. So let's start with that. What number would go on the left? Yep.
-3.
Yep, you put a -3 on the left. What number would go on the right?
5.
Yep, 5. And which way, well actually, what symbol would I put between the -3 and the x? Be a less than. Now how about between the x and the 5? Less than or equal to, yeah. So this means x has to be bigger than -3 and less than or equal to 5. That's an inequality. And it's bounded. Okay? It starts at -3, stops at +5. Questions on that? Okay, so that was bounded. How about this one? Is this interval bounded or unbounded? It's unbounded. Yes, it's unbounded. So when it's unbounded, your inequality is a little simpler. You don't have to do a conjunction. You just need a letter, a symbol, and then a number. So if somebody were to look at this, kind of like I just asked on the other page, what numbers does this basically mean you're allowed to pick?
Everything beyond -4.
Anything greater than or equal to
All real
-4.
numbers would be -infinity to infinity. So this one isn't all real numbers. Yeah?
X is greater than or equal to anything that greater than or equal to -4.
Yeah. You can pick any number greater than or equal to -4. Sometimes some people write that and then they write and x is less than infinity. Do you have to write x is less than infinity? No. Everything is less than infinity. So you just have to write it's a simpler inequality when it's unbounded. Okay. Bounded, you got to do a conjunction. That's that one. Let's try this one. Is this one bounded or unbounded? Bounded, so it's a little bit more complicated inequality. You got to put the letter in the middle. And then what number would go on the left?
-8.
Yep, pretty much the way it looks when you write it as an interval. And the right? -3. And both inequality symbols are going to be
That's less than 2.
less than or equal to. Okay, so any question on taking an interval and writing it as a inequality? Okay. Now, let's try taking an inequality and doing a graph. So when you want to change an inequality to a graph, first thing we have to decide is what kind of circle would we put on the two? Yep.
Closed circle.
Closed circle. Then we have to choose which way we're going to shade. Yeah. Which way would we shade?
To the right.
Shade to the right. And that's taking an inequality and changing it to a graph. Any question on it? Let's try this one. Well, another question I could ask. Is this bounded or unbounded? Unbounded, because there's an arrow, means it just keeps going forever. It doesn't stop. Let's try this one. X is less than 5. Set up your number line. What kind of circle do we need on the 5? Yeah, it's going to be open. And then which way do we shade for this one? Yeah, this time we're going to shade to the left. Shade everything left. Bounded or unbounded?
Unbounded.
Unbounded again, because there's an arrow. It just keeps going. It doesn't stop. Alright, and let's try this one. Okay, so we're going to need the number line from -1 to 3. That's good enough. Alright, how many circles do I need this time?
2.
I need 2. What kind of circle on -1? Closed. And what about the other circle on 3? That's open. And where do I shade? Yeah, this is the interval between -1 and 3. So it's everything between. Conjunctions, usually you shade between. If you have an or, which we'll talk about, you usually end up shading opposite directions. Any question on writing an inequality as a graph? So when we're solving an inequality, we pretty much use the same steps as when we solve an equation, but there's one thing we have to be careful about with inequalities. Yeah. Yeah, just saying. Does anybody remember what kind of number you can multiply or divide by? And if you do this, you have to flip the sign.
Is it a negative?
Yeah, it's a negative. So if you multiply or divide, not add or subtract, just multiply or divide each side by a negative, you have to flip the sign. All right, so that's something that's it didn't come up yesterday because we weren't talking about inequalities, but it does come up today. Okay, how many people remember that from? It would have been like Algebra 1, maybe Algebra 2. You would have done it too. Yeah. Okay. try that example. Now, depending on how we solve this, we may or may not end up by dividing both sides by a negative at the end. Kind of depends on how we choose to do it as we go. Well, the first step, you don't really have any choice. What's the first thing you have to do on the left side? Yep.
Distribute.
Right, you got to distribute that 3 out. And Alex, if I distribute that 3 out, what's that going to give me on the left side?
Here, which one?
Yeah.
3x minus 3 plus 2.
Yep. So 3x minus 3 plus 2. And nothing happens on the right. Alex, what can I still do on the... Still got a little bit more on the left side.
Combining terms.
Yeah, we got to combine these like terms. And what do you get if you combine your like terms?
-1 or -1.
Yep, so 3x minus 1 is less than or equal to 5x plus 6. Bless you. We still haven't multiplied or divided by a negative, so we haven't had to flip the sign at all. Now, this is going to decide what ends up happening. Isaiah, what do you want to do next?
Either move the numbers or the x's to one side.
Okay.
So add 1 to both sides.
All right, so we're going to add 1 to both sides. So we can do that. Anything else we can do at the same time?
And the x's. So subtract 5x
Mhm.
from both sides.
So we can subtract the 5x. And Jacob on the left side, what is that going to give me?
Negative 2x.
Negative 2x. Yep. And Lily Rose on the right side, what's that going to give me?
7.
Yep, it's going to give me 7. Okay, now because of how we solve that, let's see what happens. What's my last step?
I divided both sides by -2.
We have to divide both sides by -2. So that's going to cancel. Since I'm dividing by a negative, what do I have to do?
Flip the sign.
I have to flip the sign now. So x is greater than or equal to. And whether you put the negative in the top or the bottom of the fraction, that would be marked the same. So that's how you solve inequality. Okay, any questions on that? Probably review for most people. But if not, just ask me some questions so we make sure we know what's going on. Yeah. Okay, so how can you solve an inequality on the calculator? There's 2 ways. We're going to solve a very simple problem so we can actually figure out what the answer is by hand. And then we'll check it on the calculator. So one way to solve an inequality on the calculator is to move everything to one side. Okay? We'll get everything on one side, and we're going to get 0 on the other. And then we're going to calculate a root. Okay, I think we've done that before. Okay, using the second calc root. It's also called 0. And then once you calculate that root, the answer is either going to be everything below the root, could be below or equal, depends, or the answer is going to be everything above the root, could be above or equal. But it's either below or equal or above or equal. We just have to figure out what we're looking for. So it's going to kind of matter, what do they want? Do they want to know where the graph is negative, or do they want to know where it's positive? We just have to give them the right answer. So let me kind of show you an example going through those 3 steps. Okay, so there's the inequality that we're going to solve. 4x minus 1 is less than 2. Now, realistically, this is never a problem I would bother on the calculator with, because if I do it off to the side, I can solve it quicker than you probably can even hit y equals. So I mean, it's not that hard of a problem to solve. But eventually we might get problems that are harder to solve or that we maybe even can't solve by hand, and then we'll be able to use the calculator. But that's what we're looking for. We're looking for x is less than 3/4. So let's try it on the calculator and see if we get the same thing. Okay, get 0 on one side of the inequality. What could you subtract on both sides so you'd end up with 0 on the right?
-2.
Yeah, we'll just -2. -2. And what's that going to give me on the left?
4x minus 3.
Okay, so that's what we're going to type in on the calculator. 4x minus 3. Okay, so put that in. I didn't have anything in already, but if you did, you could just clear it, put in 4x minus 3. I think the standard window, that's going to be good. You just do zoom 6. And let's see what we're looking at. We are looking for the part of the graph that is less than 0. Less than 0 means it is below the x-axis. So we're going to be looking for this part of the line right here. That's the part of the line that's less than 0. Now, can it equal 0 in this problem? No, it has to be less than 0. It's almost like we have an open circle right there. It's everything from here down. Well, what we need to find is this number. I mean, we already know what the number is, but pretend we don't know the number. We're going to calculate the root and find out what that number is. Okay, so on the calculator, second calc, option 0. And you have to pick a point to the left of your root, to the right of your root. And the guess doesn't really matter because it's only crossing the x-axis one time. So we just hit enter. And it tells us exactly where it crosses the x-axis, 0.75. So now the answer is either everything less than 0.75 or it's everything more than 0.75. We want to end up on this section of the line. If you want to end up on that section, would you pick x values that are bigger than 0.75 or smaller? Yeah, you pick values that are smaller. If you pick values that are bigger than 0.75, like if you pick x is 2, when x is 2, you're like way up there. You're not less than 0. You're up at like 9 or something. Okay, it's up. It goes up pretty high. If you pick x values that are less than this, you're going to end up way down there, and that's definitely less than 0. So that's one way that you can find or solve an inequality on the calculator. Any questions on that method? So that method does involve a little bit of work because you're going to get 0 on one side. The second method, you don't have to do that. You're just going to leave the problem the way they give it to you. We'll do the same question again. Leave the 4x minus 1 on one side and leave the 2 on the other. And what you're going to do is put the left side in y1, put the right side in y2. So 4x minus 1, 2. And just so we remember which one is which, the 4x minus 1 is blue on my calculator, and the 2 is red. All right, so we're going to graph them. But we're going to look for where the blue graph is under the red graph. That's what we want to know this time. So we're not looking at a 0 because doesn't have 0 on one side. We're looking for where the blue is under the red. So there's the blue. There's the red. And I got to calculate something, but this time it's not a 0. Anyone have a guess what I'm going to calculate this time? Yeah?
The intersection point.
Yep. I'm going to calculate the intersection point. And then your answer is either going to be everything below the intersection point or everything above. It depends what you're looking for. In our case, we want everything where the blue is under the red. So let's do second calc intersect. And I don't know how well you can read it, but it says the intersection point is 0.75. That's where they cross. So once you calculate the intersect, determine, do you want all the x's that are below the number we just found? Or do you want the ones that are above? So, example 5 is the same problem. We're just doing it again. It's what I already have on the board. So in this case, do you want the x values that are below 0.75 or above? Yeah.
Below.
Yeah. Yep, you definitely want to be below. If you're above, you're going to have a point up here, which is above the red line. You don't want to be above it. You want to be below. So which way you choose to solve it, it doesn't matter. You can use the intersect method, or you can calculate the 0 and use that method. If you do it right, it'll come out the same. Any question on that? Again, this is not a problem I would ever bother because you can just add 1 and divide by 4 a lot faster than you can graph it. This is good when you start getting into inequalities that are a lot harder to do, or maybe we even don't know how to do by hand. You can always look at the picture and get the answer that way. Okay, so a double, or it's really like a compound inequality. There's really 2 methods. And this time the methods are, well, I guess they're interchangeable, but one way is easier than the other depending on the problem. Okay? So one method is to split the problem up. If I was going to solve this problem by splitting it up, this is what I would do. I would write -8 is less than 2x, and 2x is less than 12. That's how I would solve this problem by splitting it up. And now I would solve each one of them separately. So I would divide by 2 for the first one, and then I'd divide each side by 2 for the second one. And I would get x is greater than -4, and x is less than 6. But this problem, you don't have to split it. The only time you have to split it is when you have multiple variables. That's the only time you need to split it. What would multiple variables look like? Something like this. So when you have x's in more than one spot. When you have x's in more than one spot, you definitely have to do this method of splitting it into 2 problems and solving each one separate. But when you only have an x in one spot, I'm going to show you an easier method than splitting it up. So we'll call this one, this is like method 1, the split method. This is going to be method 2. This is going to be to get the x alone in the middle, which you can do as long as you don't have multiple variables. There's just one variable right there. And the way you get the x alone is look at what's next to the x and decide, okay, well, how would I get rid of it? In this case, you have a 2 times x. How would you get rid of multiplying x times 2? Would you undo that? Yeah.
Divide by 2.
Right. You divide by 2. And if you do it in the middle, then you have to do it on the left and on the right. So in this case, you divide everything by 2, and then you get -4 is less than x, which is less than 6. It's exactly the same thing you get if you do the split method, but it's easier to isolate the x in the middle doing it this way. Again, as long as you don't have multiple variables. If you've got x's in multiple spots, forget about trying to isolate x in the middle. Not going to happen. You have to use the first method, splitting it into 2 problems.
If you have multiple variables.
Yeah.
Okay.
If you only have to split it into 2 problems when you have multiple variables. So if you had something like this, -8x is less than 3x plus 2, which is less than 5. There's no way you're ever going to get that 3x alone in the middle. You're not going to be able to get rid of the 3 and the 2. So what you have to do is take and write this part first. So the first thing you're going to do is solve that, and then solve this. Solve each one of them separate. That's the only way to do that problem. Now, if this x wasn't here, then sure. Now you could do the method I described earlier because you don't have multiple variables. You just have the x in the middle. Okay. But that's not how I originally wrote it. Yeah, someone have a question? And to solve it, you just bring all your x's to one side, so minus the 3x, and then divide, and you'll be done. All right, let's try this one. Is this one where you have to split it into 2 problems, or can you isolate the x in the middle?
Isolate.
Yeah, you can isolate it because you don't have multiple variables. You just have the letter x one time. I'll give you a hint. The first thing we need to do is multiply everything by something. Yeah, and I kind of did this in the homework when I get rid of fractions. Multiply everything by 3. Now, did we multiply by a negative? No. So there's no reason to flip anything. If you multiplied by a negative in this step, you're going to be flipping the sign right now. Okay. What do you get on the left side?
You get
-9.
-9.
Okay. How about in the middle? The 3's are going to cancel, so what are you left with?
2x plus 5.
Just 2x plus 5. And the right side? 15. Okay, so there's the first step. What would be the second step?
I had a question on the first part. Are you just multiplying to get rid of the 3 on the bottom?
We're just trying to get rid of that 3, yeah. So we're trying to get this x, we're trying to isolate the x in the middle. Yep. What would be the next thing you could do?
Subtract 5.
You could subtract 5 from the left, the middle, and the right. What does that give me on the left side now?
-14.
-14. Middle,
2x.
2x, and the right, 10. So now we just about got the x alone. The last thing is to just get rid of that 2
Divide by 2.
by dividing by 2. And once you simplify, there's your answer. So -7 is less than x, and x is less than or equal to 5. Much easier when you don't have letters in multiple spots. Okay. Question on that before we look at the last thing. Okay, so the last thing we did yesterday was we solved equations that had absolute value. Today, it's going to be inequalities with absolute value. Now, does anybody remember yesterday when we said you're starting to solve an equation with an absolute value, what's the first thing you have to make sure with the absolute value?
Make sure the bars by themselves.
Make sure the bars are by themselves. And that's the same thing you have to do first here. Make sure you isolate the absolute value, and then we're going to split it into two problems. Now, the first one that's the simple one. You just take the original problem and you get rid of the bars. So the first inequality is the same as the original, just remove the bars. Now the second one is going to be very similar to what we did yesterday. Does anybody remember what did we do for the second one? We took out the bars, but we had like an extra thing. Yep. We made the number on the other side negative. But now remember, we're working with inequalities. What else do we automatically have to do if we change the sign of something on the other side? We got to flip it. Yes. So that's the extra thing today. So the second inequality is the same as the original, except you change the sign of the number on the other side, and you have to flip the inequality. So if I was doing something like this, one inequality would be 2x plus 3 is less than 4, and the other one is 2x plus 3 is greater than negative 4. Those are the two you would split that into. Now, there's one more thing we have to do. There's a word that we need to write. When we have a conjunction, what's the word that we used? And. And the other word that I mentioned you could use with inequalities is?
Or.
We have to decide whether we're supposed to put the word and or the word or. To figure out if it's an and or an or, it all depends on what I just circled. If you look at the inequality symbol, all right, have a good one. You look at that inequality symbol. If the original inequality symbol is a less than, the original problem has a less than, or a less than or equal to, you need to write the word and between the two things you just split into. If the original problem had a greater than or a greater than or equal to, you put the word or. And the way I remember it is if you pronounce this symbol or those symbols, instead of saying greater than and greater than or equal to, if you say it like greater, like it's a greater symbol, greater or, you might remember it that way. So a greater is an or, less than is an and. So if you look at this one, that's a less than. What word would go on that line? Yeah, less than is an and. And then you would solve it. All right, let's do this one. I'm just going to change. I don't like having a bunch of the same number. That can be confusing. Let's do that. So absolute value of x minus 3 is less than 8. Yeah. Okay, first step. Isolate the absolute value. What do we think? Is the absolute value by itself.
Yeah.
Yeah, so nothing you need to do for that. So we are ready to split it right away. Can someone give me the first one you split it into? This is the simpler one. Yeah.
X minus 3.
First one's plus 3.
Anything else you need? We have to split it into two inequalities. So right now we don't have an inequality there.
X minus 3 is less than 8.
Less than 8, yep. So x minus 3 is less than 8. And what about the second inequality?
X minus 3 is greater than negative.
Flip the sign and make the other number negative. Now, so we don't forget the word, that's a less than. What word goes between them? And. That makes a big difference whether you put and or or. And. All right. And now we just solve it. So add 3. And that gives me x is less than 11. And now we solve the other one. It's less than 11, but bigger than negative 5. Okay, and a graph, just set up a number line. Let's see, so I'm just going to go negative 5, 0. We'll just kind of estimate. What kind of circle on 11? Open. What kind of circle on negative 5?
Open.
Open. And where do we shade? In between. Okay, I think I mentioned earlier, but an and you usually shade between, and an or you shade in opposite directions. Any questions on that? I'm going to skip that one. That's just a greater than problem. And yeah, let's finish up with this one. So this is a solve. And it says x plus 3 divided by x minus 2 is greater than 0. Well, that's a fraction on the left-hand side. Don't even look at the actual values. Pretend this was your fraction. So you have something divided by something is greater than 0. How can you divide two things and have it be bigger than 0?
They have to be full numbers.
They have to be what?
Numbers bigger than negative.
I can think of a negative number and another negative number, and if I divide them, it does come out greater than 0. So I'm thinking there's actually like two cases. Yeah?
They just have to be of the same sign.
Yeah, they have to be of the same sign. So you either have a,
Positive, negative, negative.
you either divide a positive by a positive, and that'll work, or you divide a negative by a negative. Either one of those will give you a result bigger than 0. Now, go back up and look at our problem. One of those cases is impossible here. Anybody see which one of these would never happen? Yeah?
The negative because it's an absolute value.
Yeah, you're guaranteed that the bottom is always going to be a positive. You can't do anything about that. The bottom is always positive. So what does that mean the top has to be then? We're kind of forced into what case?
It has to be positive.
The top has to be positive. So if you can figure out when the top is positive, that will answer this question. That's all you need to figure out, because the bottom is always positive. So all you need to do is figure out is when is that greater than 0? When is the top positive? And that would be when x is what? Yep.
Greater than -3.
Okay. So x has to be a number bigger than -3 to make sure the top is positive. Is there any number that's bigger than -3 that you can't plug into that problem?
Infinity.
Well, number. Number, actual number. Is there any number bigger than -3 that you can't plug into that? Remember, this is your original problem. Right there. Yep.
2.
Why can't you plug in 2? If you plug 2 in the top, it's fine. 2 plus 3 is 5. That's a positive
Yeah,
number.
but if you put 2 on the bottom, it would be divided by 0.
You'd be dividing by 0. So that's the catch on this problem. X can be any number bigger than -3, but it can't be the number 2. So anything bigger than -3, but not equal to 2. And that's the only catch on that problem. So when you have a fraction, sometimes you get an answer, you just have to make sure you'd never divide by 0. Question on that? Okay, so the calculator stuff, that might have been a little new if you've never solved an inequality on the calculator, but hopefully most of the algebra stuff, flipping the sign and all that, that was pretty straightforward. So the homework, there was one question I was going to change. Let me just fix one question. You don't have to do number 20, was it 9? Yeah, 29. Okay, so that's homework for tonight. We'll take a look at that tomorrow. And then remember, tomorrow's the last day of new material for this week. So Thursday is going to be a review day. And then Friday, we'll have the test.